In this video, I'm going to apply the product rule with more than just two functions. We can apply the product rule anytime we have multiplication of elements of factors. It doesn't matter how many things there are there. So let me just jump right into an example. Let's take the function f of x is equal to x squared e to the x times sine x. I have three factors being multiplied here. I have the x squared, the e to the x, sine x. We can think of it as three unique functions. We have the polynomial x squared, the e to the x, the exponential, and then the trig function sine of x. In order for me to take the derivative, I am going to have to use a product rule. I'm going to kind of have to use it a couple times over. To do this, I'm going to start by grouping two of these functions. And it makes no difference which ones we group because this is just kind of for my purposes. I want to be able to apply the product rule like we know it with just two things. So I need to be able to see visually two things. I'm just grouping these first two elements and sines by itself. So now I'm going to take the derivative. The derivative tells me to leave the first thing alone, take the derivative of the second. My first thing is a little bit more complex than before. It has these two different types of functions, the polynomial and the exponential. But I'm just going to leave them alone for right now, and then I'm going to take the derivative sine. The derivative sine is cosine of x. I'm going to have to add to that. Now I'm going to leave the second function alone, the sine of x. I'm going to take the derivative of the first. Well, here's where it gets a little bit more interesting, because this first is that more complex function. It's actually two functions being multiplied together. This is itself a product rule. So I'm going to have to use a product rule within the larger product rule. So I'm going to put my brackets here just to kind of show where I'm going with this thing. With the derivative of this thing, I know that I have to leave the first, take the derivative of the second. The derivative of e to the x is just e to the x. I'm going to add to that. I'm going to leave the second, and I'm going to take the derivative of the first, and the derivative of the first is 2x. And there I have it. I'm done. I haven't simplified it, but I don't necessarily care. I'm finished. I've used the product rule in the same way that we've always done, just with three different functions. I left my first function, the thing that I grouped. I took the derivative of the second. Then I left my second. I took the derivative of the first. When I took the derivative of the first, it required me to use a little bit more. Now, if we want to, we can distribute out that sine of x. And we kind of get an interesting pattern here. Sine x, x squared, e to the x, plus e to the x. Let me just leave the sign in front so I'm consistent. Sine x, e to the x, times 2 to the x. I wouldn't necessarily write it like this, but I just want to show, in terms of order, I'd move my polynomial to the front. I want to show you that once we multiply it out, what we see here is we leave two of them as they were. We take the derivative of the third. Then we add. We leave a different pairing of two as they were. We take the derivative of the middle. And then we left the derivative of the last two. We took the derivative of the first. Let's see if we can generalize this a little bit. Let me define a function, big F of x, as f times g times h. And I'm just going to use f, g, and h instead of f of x, g of h, h of x, just for simplicity's sake. Okay? So if I take the derivative of this thing, the same way we just did a second ago, I'm going to group those first two. And so I know I leave the first two functions, I take the derivative of the third. Then I'm going to add to that. I'm going to now leave the third item. I'm going to take the derivative of the first. And so we'd have f times g, which requires our product rule. I leave the f, take the derivative of g. Then I leave the g, take the derivative of f. I'm going to distribute the h, and I'm also going to just alphabetize it this time. And so what we see here is exactly what I was talking about just a second ago, just our function is a little bit more simple. We have the derivative of each function in each of the terms. Whichever one we take the derivative of, we leave the other two alone. The same way we do the product rule. Think about the product rule with just two functions. If we have big F is defined as f times g. The derivative of f is equal to f g prime plus f prime g. We only take the derivative of one function at a time, we leave the others, and then we we are making sure we vary which one we're taking the derivative of. We can use this formula. This is a perfectly acceptable formula for the product rule 3 times over with 3 different things. We can also do exactly what I did here, which is just grouping. And I really like this grouping method because then we don't have to remember a formula. We don't have to wonder, well, what if there's 4 terms? Or what if there's 5? Well, we can just continue to group them in the same way. If I had a 4th term here, let's say I had a cosine x. Well, then I just group those 2 items next, right? Or I could group that cosine with the first one. So I just continue to do these groupings. And of course, the problem's going to get longer. It's going to get a little bit more complex just because we're going to have more to do. But we can just continue to group these things so we can continue to think of them in basic rules.